In this screencast, I'd like to show you how you can use MicroLab software to analyze data that you've collected using MicroLab. If I can draw your attention to this upper right-hand window, we can see data here, pressure volume data, that's been collected using the MicroLab pressure syringe. Over here on the y-axis are plotted pressures in units of torr versus on the x-axis corresponding volumes measured in milliliters. From the ideal gas law, we'd expect pressure and volume to be inversely related to one another. We can mathematically test that in the following way. I'm going to move over here to the left, and I'm going to click on this Add Formula button. And when I do so, a Formula Creation Tool dialog box shows up. Here, I'm going to click 1 divided by keyboard. And I'm clicking keyboard here because I measured volumes by just looking at the pressure syringe and then entered by way of the keyboard the volumes that I observed. So by entering 1 over keyboard, I'm really doing 1 over volume. To enter a label, I'm going to place in 1 divided by volume, and I'm going to enter in the units of 1 divided by milliliter, and then I'll click OK. If you notice over here in the Data Sources Variables window, the formula that we've just entered shows up. I'm going to click and drag this formula and replace keyboard milliliters as my x-axis with the formula that I've just entered. And I immediately see the data plotted as pressure versus 1 over volume. This looks pretty linear. Let's test to see how linear it actually is. Right below the graph, I'm going to click on this Analysis button, and this Graph Analysis Tools dialog box shows up. Of course, we want to add a curve fit, which is already chosen, so I'm going to click OK. At this point, when you get the Choose Graph Series dialog box, you should check to make sure that your domain listed in this dialog box matches the domain of your X data. Well, I can see this isn't going to work. My minimum is actually about 0.02 with my data, so I'm just going to change this minimum to 0.01. And if you look at the data, the maximum looks like it's about, it's at 0.1. So I'm going to make my maximum 0.11 to make sure I encapsulate all of the data. At this point, I'll go ahead and click OK. And this Add Curve Fit dialog box shows up. We'll give this the label Pressure versus 1 over V. And I want to do a first order linear fit. Before I do this, I want to go here to my actual data and look at this particular point here. I can see there's a point that sort of falls below the trend of the other data points. And that makes sense to me because when I was collecting the data, I happened to enter one of the volumes wrong. I think I entered it as 32.5 milliliters when it was really 30 milliliters. So I'm going to go ahead and right click on this particular point and choose Remove this point from the curve fit set. Automatically, we see that the linear line has been included in the curve fit, and down below we're given the equation for the line, the correlation coefficient, that's 0.996, and the standard error at about 26.5. We're going to accept and save this curve fit, and we notice that immediately updated in the graph window we see our new curve fit. Now if we go back to our curve fit that we currently have, go ahead and remove this data point again. Out here in the, actually that's going to be the low volume region because this is 1 over volume, we see that that particular data point doesn't seem to fall on the line. And there's a possible reason for this. When measuring the volumes using the MicroLab pressure sensor, I was just reading the volumes directly off of the syringe. And so if I saw the plunger pulled out to 10 mils, I assumed there was 10 milliliters of gas in the syringe. However, when using the pressure syringe, you should recognize that there is a tube that connects the syringe to the pressure sensor. That tube contains some gas. I'm guessing it contains about 2 mils worth of gas. So really, when the pressure syringe is pulled out 10 mils, it might be really around 12 milliliters of gas. So let's see if we can't correct for this. To do this, I'm going to go over here to add a formula. And in this case, what I'm going to do for my formula is do 1 divided by the measured volume, which again is in keyboard. Whoops, excuse me. Let me back that up. I made a mistake. So to do so, I'm going to hit delete here. I actually need to put this denominator in parentheses. So I'm going to click left parentheses, keyboard, plus 2, close parentheses. And by doing this, I'm saying that the measured volume, if it's actually the true volume, I'm going to need to add 2 milliliters to that. My label here, I'm just going to call this 1 divided by true volume. And this is going to be in units of 1 divided by milliliter. Now I'll click OK. And it looks like at this point what I'm going to want to do, if you see here on the x-axis, I have the 1 divided by volume. I want to place the new formula I just did on the x-axis. So I'll move this here. Now I see these new data have been plotted. I have pressure in torr on the y, again divided by, versus 1 over the true volume, where I've added 2 mils to each volume and then taken the inverse of that. Once again, I'm going to analyze these data using a curve fit. It looks like my domain matches my data, so I'm going to click OK. I'm going to remove this erroneous data point, and it looks like the first order linear shows up immediately. And you might notice that my correlation coefficient's a little better, 0.999, and my standard error has dropped from over 26 to 13.5. So this is probably a better fit. I'm going to accept and save this. Oh, got to do a label first, don't I? So we're going to call this 1 divided by measured, we're going to do pressure versus 1 divided by measured volume plus 2 milliliters. And we hit accept and save this calibration. Well, I hope that shows you how you can use the MicroLab formula tool to analyze data in MicroLab. And hopefully by watching this, you may be able to help your students analyze their data a little more deeply after they've collected it.